Good morning, good afternoon, and good evening, everyone. Welcome to this ATG webinar, Dynamo Views to Sheets. It is 11 a.m. here in Phoenix. My name is Patrick Podeyn. I will be your presenter today. I'm an AEC Technical Specialist here at ATG in the Phoenix office. A little bit about who I am before we begin. If you've been in my webinars before, you've seen this slide multiple times. If you're new, I'm an Autodesk certified professional in Revit architecture and structure, lightly seasoned Dynamo user and trainer is what I like to consider myself. I'm also a seasoned amateur golfer, and I'm a huge foodie. Living here in the Valley, there's lots of options for food. I am on Twitter. My Twitter handle is @TheNotoriousBIM, but I am also on LinkedIn. I do tend to post majority of the things that I do in Dynamo and in Revit on LinkedIn. So course description, right? We're going to go and talk about how we go to place views onto sheets. We've had a couple webinars already where we've created views through scope boxes, or maybe you have a add-on or a CTC tool that creates the views for you. And now you're looking for a way to streamline getting those views onto sheets. Maybe you also have a CTC tool to help create those sheets. Again, we need to find a way to place those views onto sheets. And so some of the learning objectives today, we're going to highlight some of the areas where these workflows, you can utilize them and think about ways to modify these workflows to utilize within your company standards, get some more practice working in the Dynamo environment. We're also going to use a couple custom nodes here and there, and then also taking away some of the logic that we learned here today to build either onto the workflows that I show for you guys, and then other workflows in the future. So let's look at some of the nodes that are at our disposal. There might be more out there due to other additional custom packages. These are just the ones that I've seen utilized the most. We've seen, if you've been on the Dynamo forums quite a bit, you're quite aware of the out-of-the-box methods to placing views onto sheets. There's one method for placing multiple views onto sheets, and if you've worked with it some, you might have run into a couple of examples where it doesn't quite work just because the viewport itself is a lot bigger than the actual title block. So this one does the method for views. This one does it one view per sheet. It does create the sheet for you, so there is no need really to create the sheets for the most part at the beginning. This next node here, the viewport by sheet view location. This one is a new node. These are all pulled from Dynamo for Revit 2021. So this node is quite similar to Rhythm's viewport.create node. We must have a sheet already created within our Revit project. We then determine a view that we're going to place on that sheet, and then we can also give it a location. For these two out-of-the-box nodes, we can't determine a location, though you can move the viewport on the sheet once it's placed, something that you can build in after you've run this method here. The sheet.pack views does almost a similar thing that these out-of-the-box nodes do. The one thing that this one will do is it will let you know if a view did not, work out on the sheet. If it did not fit, it will display that view for you to see. There's also a Steam nodes node here that will allow you to place viewports on a sheet. Virtually these three are going to accomplish the same task for the most part. So if you don't want to, download custom packages for the most part or utilize them, this viewport.by sheet location is an out-of-the-box node. Or if you are familiar and you're comfortable working with out-of-the-box nodes, or not out-of-the-box nodes, custom nodes, these two will work for you as well. So let's look a little bit at the out-of-the-box node for the placing views onto sheets. Here's a very quick example of what you need to have prepared in order to get this node to work. We need a sheet name and a sheet number in the form of a string, and so I use a code block with the name of the view and then the number of the name of the sheet and the number of the sheet enclosed in parentheses, defining that it is in fact a string. From there, we use another out-of-the-box node, family types, to determine the title block that we're going to use. So in this example, we're using a 30 by 42 horizontal title block. After that, I am using a custom node from the Archilab package to get views by type. I can input a string, or there's also a drop down for you to utilize that will give you the same exact result. Either one works in this situation. I wanted to showcase that to you. So we have our views. So we have a couple of drafting views in here that it grabbed for us. It's going into this node to place multiple views onto one sheet. And so the outcome is going to look something like this. So we have the 4 views down at the bottom left-hand corner, and it starts at the bottom left-hand corner. It works its way to the right. So that's kind of the outcome that you can come to expect when utilizing this node. Next, if we look at the singular placement of viewport onto sheet, this would be the sort of boilerplate, if you will, in how to place one view per sheet. So in this example, I have floor plans, so a level 1, 2, and a site plan using the same viewport or views.getByType node from Archilab. I am grabbing floor plans out of there. From there, I'm counting how many we have to then determine the sheet number. And so this is kind of a method here if you wanted to, go about it with the code block. So it's taking the letter A, adding it to a number, and then this method right here, I found this on the Dynamo forum, to convert that number into a string. Though you can do these with the out-of-the-box nodes, where you start with the letter A, and then you perform a range, so 1 ... however many that we have, so 3, so it'll count 1, 2, 3, and then you can convert that to a string and then add the 2 values together. I am going to call them floor plans for the most part here, so all of the sheet names are going to be called floor plans. You can have some variation with this. We might just have to play a little bit with the lists at level in order to accomplish that. So once you have that all set to go, you can kind of come to expect this method of placement. So I have my A1 sheet with the floor plan associated to it in the bottom left-hand corner, my A2 floor plan, and then my site plan as well. Again, with the out-of-the-box method, there isn't a way to determine a location on the sheet where it's placed. That's where the out-of-the-box node, that last one that I showed, and then the 2 custom nodes allow you to place that, determine that location point as it's being placed. For these methods, you would have to perform another Dynamo routine at the end of the placement of the views to then, center them or move them somewhere else onto the sheet. If we look at the rhythm sheet.pack views node, here's the boilerplate in terms of what you can come to expect or need to have in order to get this to work. We do need a sheet already created. So here I have a detail sheet created. Again, I'm grabbing all of my drafting views with the Archilab node, views.getByType. And then from there, it's going to run. I was having a little bit of issue. It might have been due to my versioning of the Dynamo of the package, but it wasn't displaying the nodes that were being successful, but it did actually work. This would be the outcome that you can expect. Again, the views are placed in the bottom left-hand corner, moving from left to right. And again, if any view did not fit onto the sheet, it would then throw an error and let you know what's going on. All right, so it's time for live example time. I wanted to showcase those workflows there. Let's get into some of the actual Dynamo of it. And so for this first example, what we're going to do is we're going to use the viewport.create node from Rhythm And what we're going to do is we're going to place all of these floor plans and all of these ceiling plans onto my already created sheets. Now you can have a workflow where the sheets are not yet created and you can have it all packaged into one. So the process would be creates the sheets first and then it starts to place those views on the sheets. You can even take it a little bit further where it creates all of the views, all of the sheets for those views and then places them on there. So in my sheets, I have a sheet order in there that'll come in handy later because we're going to need to organize our views to our sheets. So that way, when it places them on there, they'll be in the correct order. All right, so let's get into Dynamo. Again, also the workflows that I'm building today, they will be available for you to utilize after this webinar. All right, so the node that we're going to end with, right, we always want to try to start with our end node so we can identify what we need to build in order to get that node to work. So the node is from the rhythm package. It's called viewport.create. We'll see it here. So we need a sheet, we need a view, and we need a location in the form of a point. So knowing this information here, it makes it a little bit easier for us to start going and collecting that information. So we can kind of start with getting our views first. And so we're going to use the method we saw in the workflows I showed in the PowerPoint. We're going to use our a node out of Archilab, views.getByType, views.getByType. We'll place this out over here. So this is looking for the views in our file in the form of a string, right? So we can, definitely use the view types, retrieve all available view types. We can utilize this method here, but we do have to pick them one at a time, create a list, and then plug it into here. So rather than doing that, knowing that we can input a string, we can create a code block. So double click on the canvas to create a code block. We'll start with a square bracket to start developing a list of our views or view types that we wish to get. So the first one is a floor plan. It is case sensitive with no spaces. So we'll end that string there. We'll hit a comma to add the next item to our list, ceiling plan, and then area plan. Close that bracket. We'll click outside, it automatically adds that semicolon. Let's throw this in automatic mode for now. And so we can see here that we have a list of our floor plan, ceiling plan, and area plan. We can then tie this into our view type, and it's going to grab all of those view types. So we have all of our floor plans, we have all of our ceiling plans, and then we also have area plans that we want to place onto sheets. So if we look back at our file, we can see that we have one sheet with a view on it. And so we want to start to use some logic and some filtering to ignore that view that's already on the sheet. And we're going to do the same thing for sheets that have viewports on them. So that way we're not, trying to place an additional view that we don't need onto this floor plan here. So let's go back into Dynamo. And so what we're going to do is in the view itself, we click on that view, floor plan 1, and we scroll down. We have some parameter information here. So we have a sheet number and we have a referencing sheet. So we can utilize that information to filter it out. If it's not on a sheet there. So that's something we can definitely utilize in order to in a smart way, filter out those views that are on a sheet. That works for virtually all of them on here, any of the views that we have. So we're going to go and get that parameter. So we're going to get the parameter value by name, element.get parameter, parameter value by name. We're going to tie this view into the element because we're grabbing that information from those views. The parameter name is sheet number. And we can tie that into there, and we're going to see the results of the parameter values that are in there. So the ones that don't have any value at all have just those 3 dashes in there. And so we can utilize the information in there of those 3 dashes, and we can use the in a form of a string contains. So we're going to analyze these strings, and we're going to look for if it has a dash in there. Obviously, if you have dashes incorporated into your sheet numbering, this method isn't going to work. So you'll have to come up with another method to do it. There is 3 dashes in there. So you could do a string equals or equals to the 3 dashes. That works as well. Again, we're just trying to look for a method to remove the A1 sheet or view out of our list of views over here. So we're going to use a string contains, tie this into the string contains there, and we're going to search for the dash in the form of a string. We're going to tie that into the search for, and we're going to get a list of trues and falses in there. So now that we have a list of trues and falses, we can use that information to filter against our list of views. So again, we can remove that one view that is on a sheet. We'll do that with a filter by Boolean mask node. So we'll tie bool into mask, and then we'll tie our list back to our list of views back here. And if we look at this list, we'll see that that view is no longer in this list, and it is in our out. So again, all of the trues will come out of the in, and all of the falses will come out of the out. All right, so at this point, we have our views kind of set. Let's go ahead and start working on our sheets. So we're almost going to do the same process that we did here to filter out that view that was on a sheet. For the sheets, we're going to filter out the sheet that has a viewport on it. Now, this method may be something that you want to do, may not be something that you need to do. Just depends on what's going on in your template. So we need to collect all of our sheets. And so how we do that, again, is we're going to obtain the categories first. In the category, we're going to grab our sheets. So I'll just hit S on my keyboard. We'll scroll down till we find sheets. We're just getting the category of sheets. We now need another node to grab all elements of that category. It's called all elements of category. And we'll place this node here, connect the two, and it's going to grab all of the sheets out of our file. So again, we have that one sheet that has a viewport on it. We need to determine, that's going to be our method to figure out which sheets to filter out. And so how we find out what viewports are on sheets, we use a custom node out of the rhythm package called sheet.getViewports and views. So this node's very handy if you want to find out what viewports, views, or schedules are hiding on your sheets. You can tie this into there. It's going to take a while to kind of run as it's analyzing and going through all of that information. And then we can see all of the different schedules that we have on our sheets, the viewports, the actual view themselves. And so what we're going to find here is that we have a bunch of views that do not have, or sheets that don't have viewports on them. So we can use that information. We're going to do a count. We're going to count how many viewports are on each one of these sheets. So from viewports, if I do a watch node so we can see it a little bit easier, we can see that this first sheet has one viewport on it. That's my floor plans. We have a sections sheet on there that has multiple viewports on there. And then we have the rest of our sheets that do not have any viewports on them. Again, we're going to utilize that information in there to start filtering out those sheets. So how we can do that is we can use a list.count. So I use a list.count. I can tie that into there. And so what it's going to do first off is it's going to give us a total count of everything inside of this entire list. We want it to look one step further. So how we do that is we're going to click on this caret here, and we're going to say use at levels. Once we say use at levels, it then starts counting each item within each sub list here. So we have 1, we have 5, and we have a bunch of zeros. So knowing that we have a bunch of zeros, we can run a an equal to method in order to obtain a true false value for these values here. So we'll just right click, equal, equal. So equal, equal, right? There is a equal with tolerance. We don't want to use that one. We want to use X equal to Y. So we'll place that there. So we'll place our count into our Y. And then in our X, we want to create another code block, and we'll just type in the number 0. If it highlights blue, it is a number. We don't want this enclosed in quotation marks, right? If we tie that into there, we're going to get nothing but falses, and so that's not what we want. So we want to make sure that this is an integer or a number. So once we change this to a number, right, we get 2 falses, and then we get a bunch of trues. Maybe if you have viewports on there that you want to, you have in there by default, maybe this number isn't 0, maybe it's, you want to analyze if it's greater than a certain number, greater than 1, greater than 3, kind of depends on what's inside of your template. So we're filtering by the amount of viewports on the sheets. So we have 1, 5, and a bunch of zeros, and we want to grab those zeros. We want to filter for those, right? So if we have a series of trues and falses, we can now use our filter by Boolean mask node. Filter by bool mask. We'll tie our trues and falses into our mask. And again, the list that we're working on, it's not this one here, it's our list of sheets back here. So we'll tie elements into our list here. And if we look at them, those views or those sheets that have multiple viewports on them are no longer within this list. So you're looking at this and you're wondering, okay, we can probably now tie in our sheets into our sheet, our views into our view, and then define a location. We're not quite done yet. If we look at the list of sheets here, and we look at the list of views here, we have to do some more sort of logic associated to them. We need to sort them in a way. So if we look at this here, we have floor two, that works out fine, but we have a site plan that comes right after that floor plan. In this list, our site plan comes at the end. And if you remember correctly, I utilize that sheet order on my sheets. So I can now utilize that information and sort the sheets that are in that list by this sheet order. So 0, 1, 2, 3, so on and so forth. So we're going to utilize that information and sort them by that information. So we're going to do a get parameter value by name. Whoops. One word, not spaces. Get element or get parameter by name. Get parameter value by name from our into our element, and then parameter name is going to be the sheet order. That is a project parameter that I did create. And then we'll connect that into there, and then we'll see the parameter values as they relate to the sheets. This would be another area where you would need to curate it and modify it maybe a bit depending on how your sheet setup is. If there's another method that you can utilize to get your sheets in order, so that way when we do plug in our sheets into our viewport create and our views and the location, we're going to come up with the result where the right view is going to go onto the right sheet. That's what we're looking for here. All right, so how do we sort this? We're going to use a node called list.sort by key. And what this is going to do is it's going to sort our list by this key here. No need to sort this information here, as this node is already going to do that for us. Spent many a time trying to figure out why my list sort by key wasn't working. And it was because I was trying to sort this information first and then tie it in here. So to show that even further, let's go ahead and plug these two into here. You can see the result of it. So it's going to take that 0, tie it into here, and throw it to the top. So we can see the sorted keys, how it's sorting them. So 0, 2, 3, 4, 5, so on and so forth. And so now my site plan is on top. little note in here. So my parameter that I'm using, the parameter type or the data type that I am using is a number. So that may have an impact in terms of how it's going to sort if you're using text rather than a number. So do keep that in mind. So we have our sheets sorted. If we look at our views, are they in the same order? They are not. So we need to modify this a little bit in order to make sure that it looks correctly in this way. So when first building out this workflow, I did a little bit of experimentation. It took me some time to figure out, what can I utilize to make sure that all of these are going to be sorted correctly. And so I know that my level 1 floor plan is not on a sheet. And so one thing that I can use from the views is the parameter associated level. So I can sort my views by the level. I know that this view is already on the sheet, and I know this is at level 1, right? So I can utilize that information to sort my views so that way they're going to appear correctly and go onto the correct sheet. Now, this did take me some time to test out and figure out, does that truly work? Luckily enough, it does. If you have another method that you can utilize to sort your views, so that way they are going to go onto the correct sheet, go ahead and utilize that method. There may be an opportunity in here to utilize a dictionary if you have more different types of views that you're using. So we're going to get parameter value by name again. I'm just going to copy and paste this one down here, disconnect to those nodes. We're going to tie our in into our element. And for our parameter name, we're going to use a code block. We're looking for associated level. Tie that into parameter name, right? Again, we do not need to sort this information at all. This list sort by key is going to do that magic for us. So I'm just going to copy and paste that one, disconnect these nodes, tie my keys into my keys and my list into my in, and we get an error. So the reason we're getting an error is because this node doesn't exactly know what to do with the sub lists that we have here, the nested lists that we have. So we have list 1 and then sub list of all of the information for that. So how we combat that is we again use the list at level. So we're going to use levels here, and we're going to use levels here. So we're going to leave it at 2 and at 2. So that way it's just going to, instead of looking on the outside, it's going to look one more towards the inside. So once we do that, we can see here that it's going to sort our views correctly. So first up top, we have the site plan and then the entry level furniture layout, and then our floor 2, floor 3, and then our roof. It's going to then do the same thing for our ceiling plan, though we may not have needed to really sort those out, but it's just nice to kind of get those sorted as well. All right, so at this point, our views align with our sheets, and our ceiling plans align with the sheets and our area plans as well. So to make this process a little bit easier, instead of in not having to mess around with the list at level, we're just going to flatten this list. So we're going to look for a flatten node, tie our sorted list into list, and it's going to flatten them out for us here. All right, so now we are ready to start plugging inputs into this node here. So at this point, I like to go from automatic to manual, just in case I run into an infinite loop. I definitely don't want to do that. So we have our sorted list of sheets here. So we could tie that into our sheet. We could tie our list of views into our view. So now we have one last portion here, which is our location. And so you can obtain this information a couple ways. You can go into your sheet, draw some detail lines and dimension to them, right? So 1 foot 3.5 to the center, 1 foot 7.5 to the center of this drawing region here. You can also select this viewport here and then grab the information from it. And so how it places the viewport onto the sheet is we see this region around the viewport here. It's going to place it at the exact center of this viewport region that we see here. And this can be defined either by the crop region, or if we have, or by modeled geometry that we have in there, or actual annotation like a section or elevations and stuff like that. So if you want to make sure that your views go into the correct spot each and every time, my recommendation is to utilize scope boxes. Scope boxes will predefine and make sure that all of our views crop regions are to the same extent, though you may run into times where you have annotation kind of popping outside of there. So kind of just be aware of that in terms of how it's placing onto the sheet. So let's go back to Dynamo, right? And so say we wanted to, extract the center of that viewport that we have onto the sheet. So what we can do here is we can use a select model element node. Even though we're not exactly selecting a model element per se, we are selecting something that is in our drawing region. So I'll just zoom out so where I can see the viewport shown here. Come back into Dynamo, we'll hit select. We'll come back over to Revit, and then we'll just click on the viewport. As soon as we see it highlighted, we can click on it, and now we have the viewport in our view here. I don't have the location specified, so it's okay if I hit run here. It's not going to place any views onto sheets as it needs that location in order to work. So we can see here the data type that we're using is a viewport. How do we grab that location data out of that viewport? It comes from a rhythm, the rhythm package called viewport.location data. So we can click that there. We can tie our element into our viewport. We can hit run again, and it's going to give us some information. It's going to give us the bounding box, the points, and then the curves of the bounding box. So maybe there's more information here that you would like to utilize for additional workflows. It resides right here within this node. But what we care about is the viewport center, which is this one here. So if we look at the point, we have a X location of 1.619, Y location of 1.411. And so this is in a point, and what we can do here is we can tie the box center into our location. And now if we go back into Revit, I'll put this to the side, and then we can see all of these expand, right? We want to make sure, again, before we run, we have all of these in order. So my site plan, floor plans, and then my ceiling plans, and then area plans. All right, we're good to go. We can hit run. So depending on how many views you're placing on the sheets, this could take a while, or it can be fairly quick. So we'll kind of just let this one run for a second. And so we can see here that the sheets now have an extension onto it or another tree. So if we click on site plan, we can see that place the site plan in the same location as this floor plan. If we go to floor plan 2, right? Same geometry, same bounding box here. It's going to place it in the center. Floor plan 3, same thing here. 4, and let's jump to a ceiling plan just to see that. Jump to an area plan just to see that. So very quickly, we were able to place all of those views onto sheets, utilizing the location point of our already placed view that is on a sheet. So pretty useful workflow here. Now the fun thing with this too is if I just disconnect this for a second and I hit run one more time by hitting F5, right? Since we're already, filtering out views that are onto sheets, and we have more views created, more sheets created, we can actually just reuse this workflow here. You may want to double check to see that everything kind of filters out correctly, but for the most part, we can reuse this workflow to place additional views that are created onto additional sheets. Right, so that is that workflow. There is one more method that I want to show just to show how we can speed some of these things up, or just a quick and dirty method to placing views onto sheets. So I'm just going to undo this here, and I'm going to delete all of this information here. Again, this is being recorded, so you'll be able to go back to it, and then you'll get the finished workflows for you to use. So for this one to work, right, we're going to use the same node viewport.create. And we're going to use a node out of Spring Nodes, which allows us to get the current selection. So what I'm going to do here is I'm just going to grab these 3 floor plans. So what you want to do before you place the node is you want to select all of the items that you wish to put on or grab per se before placing the node. And the node that we're looking for is called collect.current selection. To my understanding, this is the only node that will allow us to grab stuff out of the project browser, though it does have some limitations. I believe we're not able to grab stuff in the family portion of it, specifically different types. So I wouldn't be able to grab stuff like that I've seen in the past in terms of limitations there. But it does work for views. Let's go ahead and select these one more time. We'll set this to automatic, and we'll see that it populates with those floor plans in there. Now what we're going to do is we're going to go grab some sheets. I'm just going to grab these 3 right here. We're going to do the same thing, collect.current selection. As soon as I place this one, it's going to maintain those sheets in there. So you may be wondering, what's this refresh for? So what you can do is you can actually place a toggle in there. So if I look for true, false, and if I refresh this with a false, right, it's going to update that selection. If I want to reset that back, right, I can just toggle this to true and that's going to reset. As long as we don't tie anything into these refresh nodes, it's going to maintain the selection that we had originally picked, right? So as soon as I tie this into there, right, that's going to update back to this current selection here. So I'll change these back to these 3 views here. Toggle it to false, and we'll see that it refreshes there. Disconnect that so that way we don't run into any sort of funniness. All right, so we'll set this to a manual mode. We'll tie our elements into our sheets or actually other way around, we'll tie those into our views. Pull this one up top, and we'll tie that into sheets. Then we need to grab a location. So what I'm going to do here is just grab the origin, an origin point, so 0, 0, 0. You can utilize the same method that we did when extracting the bounding center of this viewport here. You can utilize that same method for the location. So I'll tie that point in the location. I'll hit run. Going to take a couple of seconds to go through and run that. Again, depending on how these are ordered is going to determine how they're placed onto the actual sheets themselves. So I can see here, floor 2 is on there, floor 3 is there, and then my furniture entry level is placed on there. So maybe utilizing some sort of sorting before we tie it into there to get this to work, but this would kind of be a quick method to placing views onto sheets if you don't want to go through the process of recreating the workflow that I had just created. You need something very quick, or you can't find the workflow per se, or you're not connected to the server. This would be a method to placing views quickly onto sheets, and you could do it 1 view at a time per sheet, or you could do multiple views at a time per sheet, though just be aware that you may have to resort the views that you have selected. So how to identify an XY coordinate on a sheet? So how I was able to do that was, let me go ahead and open up the workflow itself. So there is a node in there to input a value from feet and inches, right? And so for my X value, if I go to this site plan here, or this sheet here, right? So this is my X value, 1 foot 7.5, 1 foot 7.5. And then my Y value, 1 foot 3.5, 1 foot 3.5 there. And then if we draw a diagonal from our drawing region from the bottom left corner to the top right corner, we can draw a detail line kind of wherever and snap to the middle. So if I just delete that and I create another one, if you hit SM on your keyboard, it'll find the middle of the line that you're selecting or line element that you're selecting. We can then click and then draw a line kind of wherever, left, right, vertical, does not matter. And then we just dimension from here. Now, another thing to be mindful of is the units that are within Dynamo and the units that are within Revit. So if your project is in metric per se, this number from feet and inches might not work. If you try to go directly from here to here, you'll have to convert it from feet and inches to the metric units that you are using. So keep that in mind, as that has almost done me in one time. We couldn't figure out why the viewport was placing in a weird location, and it was because of the units. So another thing to keep in mind. And then once we have those created, we can just create a point by coordinates by fulfilling an X value and fulfilling a Y value. And we don't necessarily need a Z value, as we won't ever really see the viewport hovering on top of the sheet, if you will. Can these place workflows also work when there's no sheet existing? So for this one to work, there does need to be sheets created before working on this node here. Now, I did mention at the beginning that you can pack that workflow to create sheets prior to running this, and you can have it all run simultaneously within one workflow itself. That one, let's see, the node that you would use is, if I type in sheet create, right? So to create sheets, you'll want to utilize this node here. Again, it's from Rhythm, and what it's looking for is a title block. So if you're looking to create multiple sheets, you'll just have to remember to cycle that title block over and over. So if I look for, say, family types, and we grab that title block, whichever one, right? What you can use here is the amount of views that we're going to place onto sheets, which I believe comes back here. Let me disconnect these. We'll run it, hit F5 to run. So we have 9 views here. So we can use that information in order to create the appropriate amount of sheets rather than tying them each every time. Let me move these over here. So again, we have 9 views that we're going to place onto sheets. So what we can do is utilize a list.cycle node. So we can tie our list, our item that we're going to cycle multiple times, and then the amount. So what we do here is we just count the amount of items that are in this list, tie that into our amount. We hit F5, and it's going to give us a title block for all of those, because the way that this works is the amount of title block or title blocks that we tie into here is going to create that amount of sheets. So if we just tie in the family type straight into the title block, it's only going to create one sheet. So let me just highlight this, drag this over. Let me just minimize these. And what it's going to do, how it names them and numbers them, is it's just going to carry off of the original number that you have in here, and then the name is just going to be default, or I forget the default name that it applies. So let's just tie this list in title block, right? We'll hit run, and we can see here that it added on to our list. And so it started after 11 and it created 12, gave it the name unnamed, unnamed, unnamed. So then from here, what you can do is create another method off to the side to then make sure that those sheets are numbered correctly as well as named correctly. I believe in a previous workflow or webinar that I did, I went through and showed how to create sheets, and then I believe also placing some views onto sheets. What would be the process for getting location of view from a sheet linked in a architectural model? So from that, my thought process with trying to do that is using the rhythm nodes to access files within a linked model. And then from there, you might be able to grab those sheets. And then from those sheets, you might be able to grab the actual viewport that's on those sheets to then grab the center location point out of those sheets. Again, that would be utilizing the rhythm node. Forgive me, I kind of forget from time to time where these nodes are at. I believe it is one of these. It's a node within Rhythm. I always have to look up which one it is, but there are two nodes in there, one to access a linked document, and then access all of the either element types or all the categories of that that live within that Revit model. And so from there, you should, I say should, I haven't tried it out myself, but you should be able to grab the sheets that are in there, as well as the viewports that are on those sheets. So go ahead and give that a try. Thank you again for attending this webinar. Hope you guys gained something out of it. As always, do have a good rest of your day, the rest of your week, and stay safe out there. Thank you.